this video I show you how to perform an examination of the anal canal with the BK 3000 and 5000. We start with the mandatory entry of patient ID. We fill out these values and press continue. Then we get to the probe selection and click on the desired probe, in this case 20R3 or X14L4. This leads us to the menu item presets. Here we can choose whatever we want to examine, the anal canal or rectum. We're choosing colorectal and anal. Now another menu appears with frequency, dynamic range, resolution, and so on. In these scanners, these parameters have been greatly simplified and fully automated. However, I will explain why these settings are so important. We start with frequency, depth, width, resolution, distance, and acquisition time. The frequency, we can choose it here, and what we should know is the closer the examined object to the transducer center, the higher the frequency should be chosen. For the assessment of the anal sphincter, the highest possible level, for example 14 MHz at this probe and 16 MHz in this one, should be chosen. For another view, we should choose between 9 and 10 MHz. This allows to show structures that are farther away from the probe properly as well. For depth settings, we need to realize how far into the tissue we want to see. That means how far the structures examined from the probe center is. It's meaningless to set the depth to 10 centimeters and try to examine the sphincter muscle, which is just 1 or 2 centimeters away. The same goes for width. Here we have to realize how wide the picture should be, just to obtain the whole structure you are interested in. This happens similar to depth settings and is in this scanner already done. These parameters have to be modified when changing from detailed to overview recordings. Resolution describes the moving rotation speed in the probe and thus indirectly the time takes to describe the record of 360 degrees. This rotation is of course not only performed once but repeated again and again. If these 360 degrees are walked in a long time, the probe has more time to obtain more particular images. This makes our 3D image more accurate. If on the other hand the velocity is raised, the 360 degrees rotation takes shorter and the probe has less time for this recording. The picture is getting worse in quality. It contains, so to speak, less information. So the reduction of resolution leads to an extension of the recording time, but increases the image quality. In this scanner it has been simplified and we can let the resolution in standard position. The distance, to find in the 3D card, and spacing. It describes the distance of the individual sections of our 3D image cube to each other. The smaller the distance between the cuts, the more accurate the final 3D image. It is a big difference whether we have 10 or 300 frames in a 6 cm 3D box. The simple thing here is the more the better in terms of quality. But the more frames in the box, the longer it takes the device to obtain these pictures. When assessing the anal canal, if no disturbing factors, for example pain, are present, this distance should be chosen as long as possible, 0.2 millimeters. In summary, we can say for our 3D sonography assessment, frequency for other view recordings 9 until 10 MHz, for the detailed recording as high as possible, so we choose 16 or in this probe 14. Depth, depending on the location of the organ to be examined, and width as well. Resolution, normally the slower the better. In this scanner we can let it in the standard position. Distance, the smaller the better. 0.2 millimeters are preferable. Acquisition time, inversely proportional to the distance. The higher the distances, the lower the recording time, but the worse the recording results. So how should we choose our settings for the 3D sonography of the anal canal? Megahertz. Overview 10 MHz. Detailed recordings, for example sphincter, 16 MHz. Depth and width, depending on the position of the organ to be examined, 1 until 5 centimeters. Resolution as low as possible. And in this device, we'll let it in the standard position. Distance 0.2 millimeters. Acquisition time then will be about 60 till 90 seconds. As we see, it is not difficult to choose the right parameters for the 3D sonography. This is how your diagnostic will surely be successful and reliable. Thank you very much.